Hello and welcome to this lesson. In this lesson, we are going to learn how to convert a binary fraction to a decimal number. We are going to convert the binary fraction 1101.101 in base 2 to a decimal number. If you look at the binary place value chart, you realize that when solving binary problems that have a decimal point called the radix, the digits after the radix are treated as fractions. So, come along and let's learn how to convert this number in base 2 to the equivalent number in base 10. In previous lessons, we learned about the place values when solving binary numbers. However, there is a little twist here. After the radix, the place values become negative numbers starting from -1, -2, and so on. After you understand the correct place values for each of the binary numbers, then we can begin to solve. Before we go on, please like and share our page and videos on Facebook, follow and like Learnifik on Instagram, and subscribe to our channel on YouTube. After you subscribe on YouTube, click on the bell icon to get notifications when new videos are uploaded for you. Also, stick around to the end because I will show you a much faster method to convert binary numbers to decimal numbers. Now let's convert this binary fraction. First, we multiply 1 starting on the left by the base 2 raised to the power of 3, which is a place value of the first digit, which we add to the next number, that is 1 multiplied by 2 raised to the power of 2. Then the next digit, which is 0 multiplied by 2 raised to the power of 1, and so on. When we get to the radix part, the place values takes a different approach. Now we have 1 multiplied by 2 raised to the power of -1, 0 multiplied by 2 raised to the power of -2, plus 1 multiplied by 2 raised to the power of -3. So we have 1 multiplied by 8, which is the equivalent of 2 raised to the power of 3, plus the next number, 1 multiplied by 4, plus 0 multiplied by 2, plus 1 multiplied by 1, and now back to the radix section. We have 1 multiplied by 1 divided by 2 raised to the power 1. We have this arrangement because of the laws of exponents as shown on the screen. We continue for the second digit. We have 0 multiplied by 1 over 2 raised to the power of 2. For the next step, we begin to add. Now we have 8 plus 4 plus 0 plus 1, which gives 13. For the radix section, we have 1 over 2 plus 1 over 8. If you have a calculator, 1 divided by 2 gives 0.5, while 1 divided by 8 gives 0.125. When we add these numbers together, it gives us 13.625 as your final answer. If you don't have a calculator, we will have to do the long division method. We have to find the LCM, that is the least common multiples, between the denominators of the fraction 1 over 2 and 1 over 8. And the LCM is 8. So 8 divided by 2 gives us 4. And 4 multiplied by 1 gives us 4. For the second fraction, 8 divided by 8 is 1. And 1 multiplied by 1 is 1. So we have as the numerators 4 plus 1, which gives us 5. And the denominator remains 8. So we have the fraction 5 divided by 8. Now we have to add 13 to 5 divided by 8. And this gives us the same answer, which is equivalent to 13.625 as your final answer. In an exam situation, to easily solve this problem, you can make use of the binary conversion table as shown on the screen. The easy thing to do is when you have this table, just fill in the binary numbers you want to convert according to their place values. So when you fill each digit according to their place values, you can easily get their equivalent. So in this case, we have 8 plus 4 plus 1 plus 0.5 plus 0.125, which gives us 13 plus 0.5 plus 0.125, which gives us the same answer we got previously, 13.625. Thank you for watching this video. Hope to see you in the next.